Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out the questions from the Mathematics Knowledge Subtest from my 7th full-length practice test on my website. In case this is your first time finding my YouTube channel, I want to mention that I recently created a website called ASVABApp.com. There, in addition to taking 3 short practice tests, you can now take 7 full-length practice tests. And once you take those practice tests, the application will give you a rough estimate of your AFQT score at the very end. If for some reason you don't want to go to my website and take this practice test, you're more than welcome to work out these questions alongside me here on YouTube. In that case, I'd recommend that you pause the video after I read each question, attempt to work out the question on your own, and then resume playing the video to check your solution. As a reminder, you're not permitted to use a reference sheet or a calculator on the ASVAB, so regardless of where you take this practice test, try not to make use of any of those resources. Finally, I want to say this. In the description of this video, there are going to be timestamps that are associated with each question. Next to the timestamp is going to be the topic that the question's testing, as well as a link to video in which I discuss that topic in greater detail. So if at any point you feel as if you need additional assistance for any of these problems, again, just check in the description and there you'll find those links to my other videos. So all that being said, let's go ahead and get started with today's video. All right, so this first question says evaluate the expression using the given values. We have 7x squared plus xy minus 2y squared when x equals -3 and y equals 6. On the ASVAB, you are going to have scratch paper, and I encourage you to use it as much as you need to. And for this problem, I'm going to start by copying down the expression that was given, notably 7x squared plus xy minus 2y squared. And I'm going to take note of the fact that we're going to let x equal -3 and y is going to be 6. The first step to solving a problem like this is to plug in -3 where we see x and 6 where we see y accordingly. So this becomes 7 -3 squared, again x is -3, plus x is -3 times y, which is 6, minus 2 y is 6 squared. All right, so a lot of people might get stuck right here. Again, you have to use your order of operations to simplify this expression now. And your order of operations are best remembered by the acronym PEMDAS, or please excuse my dear Aunt Sally. And they say work out what's in parentheses first, then move on to exponents, then do multiplication and division as they appear in the expression from left to right, and then finally work out addition and subtraction as they appear from left to right. Well, in this case, we really have nothing inside parentheses to work out, so we can't do anything there. That said, we do have exponents. We have squared here and squared here. So we're going to take care of those exponents next. This is going to become 7 times, what is -3 squared? Well, -3 squared is the same thing as -3 times -3. A negative times a negative is a positive. So -3 times -3 is going to be positive 9. So this becomes 7 times 9. And let me just say this. We include that negative in the square because it's inside parentheses. If that negative was outside parentheses, we would disregard it completely. Okay? All right. We're not going to touch -3 times 6. Again, we're only focusing on the exponents at this point. And 6 squared, we should know. 6 squared is the same as 6 times 6, which is 36. All right, so we took care of our exponents. Now we're going to work out multiplication and division as they appear from left to right. If we look through our expression one more time, you can see we have multiplication here, and multiplication here. And then we have addition and subtraction. Again, we're going to take care of that multiplication before we deal with the addition and subtraction. So 9 times 7 is 63. So this becomes 63. And then we have negative 3 times 6. A negative times a positive is a negative, so this is minus 18. And then we have a negative times a positive. Again, that's 36 times negative 2. Positive times a negative is going to be a negative. 6 times 2 is 12, carry a 1. 2 times 3 is 6, plus 1 is 7, so this is negative 72. All right, so we took care of our multiplication. There's no division. And as you can see, the only thing left is subtraction. So there's no addition to worry about. We're just going to work out this subtraction as it appears from left to right. That is to say, I'm going to do 63 minus 18. I'll do that over here. So we have 3 minus 8, which we can't do. We have to borrow. This becomes 5. This becomes 13. 13 minus 8, well, 8, 9, 10, 11, 12, 13. That's going to be 5. Then 5 minus 1 is 4. So this becomes 45 minus 72. And I recently made a video on this. Here we're subtracting one integer that's bigger than the other. So the way we're going to do this is like this. We're actually going to do 72 minus 45. But that said, since 72 is bigger than 45, we know our result has to be negative. So we know our positive answer choices are not correct. And let's work this out now. 2 minus 5 we can't do, so we have to come over here and borrow 1. This becomes 6. This becomes 12. 12 minus 5 is 7. And 6 minus 4 is 2. So we can see that when we evaluate this expression, it becomes negative 27, which is answer choice A. Kind of a difficult problem in as much as you had to know your order of operations, and beyond that, you also had to be comfortable doing this awkward subtraction by hand. All right, so that's a very good question. Questions like this frequently appear on the ASVAB, so be prepared to work them out. Number 2 says, what are the factors of x squared plus 9x plus 20? So I'm going to start, not surprisingly, by copying down this expression. We have x squared plus 9x plus 20. And let me just say this from the get-go. You do have to know how to factor for the ASVAB. You will see a question about factoring. In every practice test video I've ever made, I've always included factoring. So make sure you get good at factoring before you take this test. Otherwise, you're going to lose out on some easy points. That said, you can see we're factoring a trinomial here that has a leading coefficient of 1. And these are factored like this. And now we say we're looking for two factors that multiply to positive 20 and add to positive 9. So that's going to be plus 4 and plus 5. Again, 4 times 5 is 20. 4 plus 5 is 9. Again, there's no real way for me to show you how to work that out. If you struggle with factoring, please watch my videos on factoring. I think I have 4 of them, and they're all longer than 30 minutes. So if you need more practice with factoring, please check out those videos. They will help you tremendously. All right, so that's that one. All right, so number 3 here says, what is the area of a parallelogram if it has a base of 2x plus 1 and a height of 5x plus 7? All right, so on my website, I have a 13-page reference sheet that's completely free for you to download. That reference sheet actually took me like 4 or 5 days to make. So what I recommend is that you look through it, cross off what you already know, and then focus on memorizing any of those formulas with which you're unfamiliar. And if you look through that reference sheet closely enough, you'll see that on page 5, I have the formula to find the area of a parallelogram. And it's very easy to remember. Area of a parallelogram is simply base times height. And as it happens, we were given both of those things in this problem. We have our base, it's 2x plus 1, and we have our height, it's 5x plus 7. So let's plug those things in accordingly. this becomes 2x plus 1 times 5x plus 7. All right, so if we look at our answer choices, we can see that that is not there. And what that means is we actually have to expand this by either using the distributive property or the FOIL method. Again, those two things are the same. So I'm just going to use the distributive property. And according to that property, we're going to take this 2x and multiply it here as well as here. Then we're going to take this 1 and we're going to multiply it here as well as here. So let's get started doing that. To start, we have 2x times 5x, which is going to be 10x squared. Then we have 2x times 7, so that's going to be plus 14x. Then we have 1 times 5x, which is just 5x. And then we have 1 times 7, which is just 7. This answer choice isn't there because we actually have to combine these two like terms, notably 14x and 5x, so this becomes 10x squared plus 14 plus 5 is 19x plus 7. And as we can see, that is answer choice B. I recently made 2 videos on adding, subtracting, and multiplying polynomials. So if you struggle with that, please check those videos out. Again, I work out many examples of this right here in those videos. So again, if you struggle with polynomials, please check those videos out. That is a big part of this test. As a matter of fact, that's what the next question's about. All right, so number 4 here says, what is the sum of negative 7x to the 5th plus 14 minus 2x and 10x to the 4th plus 7x plus 5x? All right, so first of all, sum means add. So we're simply going to add these polynomials together. That said, you want to take your time as you write them down. Again, I've made mistakes simply because I copied down the question wrong. So let's take our time as we do that. We have negative 7x to the 5th plus 14 minus 2x. Again, we're finding the sum of that polynomial, so add with this other polynomial, notably 10x to the 4th plus 7x plus 5x to the 5th. All right, so of course, if we look through our answer choices, we can see that this expression is not there, and that's because we have a lot of like terms in this expression. And on the ASVAB, you always want to combine your like terms to reduce any expression you're working with. Well, what is a like term? I defined that in my video on adding and subtracting polynomials, but let me give you a quick definition here. A like term has the same variable raised to the same power. So for example, negative 7x to the 5th, our variable's x and it's raised to the 5th power. So if we scan this expression, a like term has to have x raised to the 5th power. And we can see this is x raised to the 5th power. So negative 7x to the 5th and 5x to the 5th are like terms, and therefore we can combine them. Negative 7x to the 5th plus 5x to the 5th is negative 2x to the 5th. And once we combine them, we can simply cross them out. All right, so when you simplify expressions, you want the powers on the variables to be in descending order. So we're going to go 5, 4, 3, 2, 1. So next we're going to be looking for the variable raised to the 4th power, which is right here. Of course, we don't see any other variables raised to the 4th power, so we're simply going to drag it down. This becomes 10x to the 4th, and now we can cross it out. All right, there's nothing raised to the 3rd power. There's nothing squared. So we're going to look at things raised to the 1st power, which are right here, 7x and negative 2x. Again, those are like terms. If it's helpful, you can put an imaginary 1 there. And now we can combine them. 7x minus 2x is plus 5x. Let's cross them out. And then finally, we just have plus 14. All right, so this should be an answer choice. Negative 2x to the 5th plus 10x to the 4th plus 5x plus 14. And we can see that That is right here. It's answer choice D. All right, so again, polynomials are a big part of the ASVAB. As you've seen in this video already, we've multiplied polynomials and we've added polynomials. Chances are you are going to have to multiply and either add or subtract polynomials on the ASVAB. So make sure you watch those two videos on my channel if that's something with which you struggle. I go into much greater detail in those videos and they will help you out tremendously. All right, so number 5 here says if C is -5, then what is F? Use C equals 5/9 times F minus 32. In case it's not obvious, C refers to Celsius and F refers to Fahrenheit. So for this problem, we're converting from Celsius to Fahrenheit. And if you watched my video on that, you'd know that you do not have to memorize this formula. It's not on my reference sheet for that reason. But that said, you do have to know how to plug things into this formula and solve accordingly. And this problem's an example of that. So not surprisingly, I'm going to start by copying down the formula that's given. Again, we're told C is equal 5/9 times F minus 32. We're told what C is. C is -5. And we want to solve for F. In other words, we want to get F by itself like this, F equal to something. So first things first, I'm going to plug in -5 for C. And I'm just going to copy down the rest of this formula. Again, this is 5/9 times Fahrenheit minus 32. All right, so the first thing you want to do here is clear this fraction of 5/9, and what you can do there is multiply it by its reciprocal, notably 9/5. And we're going to do that to both sides of the equation to keep it balanced. This crosses out here and here, so this just leaves you with F minus 32 on this side. And now we got to work this out. 9/5 times -5. Well, that's not that difficult to do. And I'm going to do it off to the side over here. We have 9/5 times -5. You can see that we're multiplying a fraction by a whole number. In order to proceed, I want to write this whole number as a fraction as well. So I'm simply going to place it over 1. And once I do that, I can see 5 goes into 5 one time, 5 goes into -5 -1 times. So this becomes 9 divided by 1, which is 9, times -1 divided by 1, which is -1. 9 times -1 is -9. So this is -9 here. All right, so now we're just solving for F. The last thing we have to do is add 32 to both sides. This crosses out here, leaving you with just F on this side. And this is the same thing as 32 minus 9. So 32 minus 9. 2 minus 9 we can't do, so we're going to have to borrow. This becomes 2. This becomes 12. 12 minus 9 is going to be 3, and 2 minus nothing is 2, so we can see F is 23 in this case. And in math, it's customary to write the variable for which you solved on the left. So this says F equals 23, which we should see as answer choice C. All right, so that's that one. Again, I do have a video where I work out nothing but these problems. So if you want more practice with this one, just check out that video called Converting Celsius to Fahrenheit. It's pretty helpful in that regard. All right, let's go ahead and move on to number 6 here. All right, so number 6 here says write an equation for a line that passes through the points 2, 1, and 0, 7. So we have the points 2, 1, and 0, 7. The first thing I'm going to do is label these points accordingly. I'm going to call this x1, y1, which makes this x2, y2. And the first thing you want to do when you are trying to write the equation of a line that passes through 2 points is find the slope of that line. The slope of that line is given by this formula, m equals y2 minus y1 divided by x2 minus x1. And as you can see, we already labeled the points, so this is just a matter of plugging those in accordingly. So this becomes y2 is right here, 7 minus y1, that's right here, that's 1, over x2 is right here, 0, minus x1 is right here, 2. All right, let's keep working this out. 7 minus 1 is 6. 0 minus 2 is negative 2. 6 divided by negative 2 is negative 3. So the slope of our line is negative 3. Well, all of our answers are written in this form, y equals mx plus b. And we can see our m is negative 3. So all the answer choices were m is not negative 3 are incorrect. So this one's incorrect. Again, m is negative 7. And this one's not correct. M is positive 3, and we know it's going to be negative 3. All right, so we just eliminated A and D as possible answer choices. And now we're going to work out the final thing we need to do to write this equation of the line. And that is we're going to plug in values into the point slope equation. And that's this: y minus y1 equals m times x minus x1. We know what m is, and we know what y1 and x1 are. So just plug those in. So this becomes y. What's y1? It's right here. It's 1 equals m. M is negative 3. X. What's x1? It's right here. It's 2. All right, so let's start simplifying this. This is y minus 1 equals, we have to take this negative 3 and distribute it here and here. So this becomes negative 3 times x, which is negative 3x, and negative 3 times negative 2, which is going to be positive 6. All right. Now we just want to get y by itself, so we're going to add 1 to both sides. This crosses out here, leaving you with y equals negative 3x plus 6 plus 1, which is 7. So the equation of the line that passes through these 2 points is negative 3x plus 7, which we can see is in fact b in this case. All right, so make sure you know how to do that. Questions like this frequently appear on both the PiCAT as well as the ASVAB. All right, so number 7 here says, which of the following is not a prime number? We have 61, 79, 85, and 89. All right, so just to recap, we say a number is prime if it's only divisible by 1 and itself. So 5, for example, is a prime number because it only has 2 factors, notably 1 and 5. Well, what's the trick to determining which of these numbers is not prime? Well, let's go ahead and write them out. We have 61, 79, 85, and 89. Well, we're actually going to use divisibility rules for 2, 3, 4, and 5, because if one of these numbers is divisible by 2, 3, 4, or 5, then it can't be prime. And I'm actually going to start with 5 here. The divisibility rule for 5 says this: if the last digit in a number is 0 or 5, then the number itself is divisible by 5. So we're going to be looking at all the last digits in these numbers, right here, right here, right here, and right here. What's the last digit in 61? It's 1. That's not a 0 or 5, so I know 61 is not divisible by 5. The last digit in 79 is a 9. That is not a 0 or a 5, so I know 79 is not divisible by 5. In 85, the last digit is 5, and according to the divisibility rule for 5, this means 85 is divisible by 5. And since 85 is divisible by something other than 1 in itself, we know that this is not prime. So the answer to this one is A, 85. All right, so that's that one. Number 8 here says, what is the reciprocal of 3 1/2? So we're dealing with the number 3 1/2. That is a mixed number. Well, the first thing you want to do is convert this mixed number into an improper fraction. And here's how you do that. Again, this 2 is not going to change, but you say 2 times 3 is 6 plus 1 is 7. So the improper fraction for 3 1/2 is 7 over 2. To find the reciprocal of 7 over 2, we simply exchange our numerator in our denominator, so this becomes 2 over 7. All right, so the reciprocal of 3 1/2 is 2 over 7, which we can see is B. All right, so that's that one. All right, so number 9 here says if 5 to the x power equals 625, then what is x? So we have 5 to the x equaling 625. All right, so this one takes a little bit of logic to figure out. What is 5 squared? 5 squared is the same as 5 times 5. 5 times 5 is 25. All right, so we know x is not 2. Well, what is 5 to the third? 5 to the third is the same as 5 times 5 times 5. And what is 5 times 5 times 5? That's 5 times 5, which is 25. And what's 25 times 5? That's 125. All right, so we know x is not 3 in this case. What is 5 to the fourth? 5 to the fourth is the same as 5 times 5 times 5 times 5. And what's that work out to be? 5 times 5 is 25. 25 times 5 is 125. And what's 125 times 5? Well, I can't do that mentally, so I'm going to work it off to the side. 125 times 5. 5 times 5 is 25, so we're going to drop down a 5 and carry a 2. 5 times 2 is 10, plus 2 is 12. Drop down a 2 and carry a 1. 1 times 5 is 5, plus 1 is 6. So 5 to the fourth is 625. And we can clearly see that x is 4 in this case, which is answer choice D. All right, so that's that one. All right, so number 10 here says, what is the length of the diagonal of a rectangle that has a base of 16 and a height of 12? So for this problem, it's going to be helpful to make a little diagram. Again, we know we're dealing with a rectangle which looks like this. And let's go ahead and start labeling things accordingly. We're told this rectangle has a base of 16. That would be this part right here. If this is 16, then we know this side's also 16. And we know it has a height of 12 according to the problem. So this, in other words, is 12. If this side's 12, then this side's 12. And we want to know the length of the diagonal of this rectangle. That's something we're actually going to have to draw on ourselves. Diagonal of a rectangle is right here, from there to there. When you draw a diagonal across a rectangle, what you make is two right triangles. And we can actually use the Pythagorean theorem to find the hypotenuse of a right triangle, because that's going to be the same length as this diagonal. And again, let me go ahead and pull that out so you can see it. Again, I'm going to pull out this bottom right triangle right here. All right, again, we know that this right triangle has a height of 12 and a base of 16. Well, what is the Pythagorean theorem? The Pythagorean theorem says this: a squared plus b squared equals c squared, where a and b refer to the legs of your right triangle and c refers to the hypotenuse of the right triangle. You can quickly identify the hypotenuse because it's always directly across from the right angle. So in this case, we know that this distance right here is our hypotenuse, and as we can see, that hypotenuse is the diagonal of this rectangle. Well, what the Pythagorean theorem says is this: if you're given a and b, you can find c. And in this case, we know what a and b are. I can let a be 16 and b be 12. Again, 16 and 12 are legs of this right triangle. So this becomes 16 squared plus 12 squared equals c squared. Again, we know this hypotenuse is c, and now we're just going to be solving for c. 16 squared, I can't do in my head, so I'm going to do 16 times 16. But that's it. I can do 12 squared in my head. That's 144. All right, 6 times 6 is 36, so we're going to drop down a 6 and carry a 3. 1 times 6 is 6, plus 3 is 9. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 6 is 6. 1 times 1 is 1. So this becomes 6 plus 0, which is 6. 9 plus 6, which is 15. Carry a 1. 1 plus 1, which is 2. So this becomes 256 plus 144 equals c squared. And let me move down a little bit. Let's add these together. We have 256 plus 144. 6 plus 4 is 10, so we're going to bring down a 0 and carry a 1. This is 5 plus 4, which is 9, plus 1, which is 10, so bring down a 0 and carry a 1. 1 plus 2 is 3, plus 1 is 4. So this is 400 equals c squared. Again, we just want to solve for c, not c squared, so we're going to take the square root of both sides. This crosses out here, leaving you with just c. Square root of 400, you should know, is 20. So c in this case is 20. All right, so again, c is 20, and we know that the hypotenuse of this right triangle is this diagonal, so we know this is also 20. So the answer to this one is C, 20. All right, so that's that one. Again, I think on the very first page of my reference sheet, there's the Pythagorean Theorem, so make sure you understand how to use it. All right, number 11 here says, if the perimeter of a square is 40 feet, what is its area? All right, so we're working with a square in this case, so let's go ahead and make a little diagram. And what do we know about squares? In squares, all the sides are equal. So this side's equal to this side's equal to that side, and that side's equal to that side. Well, we don't know anything about the length of the sides of this square, so I'm going to call this one S, which means this one's also S, this one's also S, and this one's also S. How do you find the perimeter of a polygon? You simply add up all of its sides. So to find the perimeter of this square, we're just going to add up all of its sides, and in that case, it's going to look like this: S plus S plus S plus S. This is the same thing as perimeter equals 4S. Well, what do we know about this square? We already know its perimeter. We know its perimeter is 40. That was given to us in the problem. So in place of P here, I can actually put 40. So this becomes 40 equals 4S. And if I divide both sides by 4, I can cross this out here, and this leaves me with S equals 40 over 4, which is just 10. So I know we're dealing with this square here in which all the sides are 10. And given that, we can now quickly find the area of this square. Again, area of a square is side squared. We know what one of those sides is. It's 10, so this is area equals 10 squared. 10 squared is the same as 10 times 10, or 100. So the area of this square is 100 square feet, which is answer choice A. All right, so that's that one. All right, so number 12 says, what is the height of a triangle that has a base of 9 feet and an area of 45 square feet? All right, so for this one, we know we're working with a triangle. That said, we don't know what type of triangle we're working with. So in light of that, you actually get to draw whatever triangle you want. And in this case, I'm simply going to draw a right triangle, since I tend to think those are the easiest to work with. All right, so there's my right triangle. In a right triangle, this would be my base, and this would be my height. And we know what some of those things are. According to the problem, our triangle has a base of 9, and we're trying to solve for height, so we don't know what that is. That said, we know the area of this triangle is 45 square feet, so its area equals 45. Well, how do you find the area of a triangle? Area of a triangle is 1/2 base times height. Again, we know what area is. So in place of A, I'm going to put 45 equals 1/2. We know what the base of this triangle is. It's 9. And by solving this equation for h, we'll have our answer. So first things first, I want to clear this fraction of 1/2. And as we've seen previously, we can simply multiply that by its reciprocal. Reciprocal of 1/2 is 2 over 1. And we have to do that to both sides. This will cross out here and here, just leaving you with 9h. And 2 over 1 is the same as just 2. Again, this is 2 divided by 1. 2 divided by 1 is 2. So this is really 2 times 45. Well, what is 2 times 45? You should know that's 90, but that said, if you really needed to, you could work it off to the side. 45 times 2. 5 times 2 is 10, so we're going to drop down a 0 and carry a 1. 4 times 2 is 8, plus 1 is 9. So this is 90 equals 9h. Again, we're just solving for h, so let's get rid of this 9 by dividing both sides by 9. This crosses out, leaving you with h over here. 90 divided by 9 is 10, so we can see h in this case is 10. So the height of this triangle is 10 feet. All right, so that's that one. All right, so number 13 says, what is the sum of the interior angles of an octagon? So if you look closely enough on my reference sheet, you'll see that there's a section in regard to telling you the number of sides each polygon has, as well as the sum of its interior angles. Well, at the very bottom of that section of the reference sheet, you'll see this formula. S equals 180 times n minus 2. And what this formula says is the sum of the interior angles of a polygon is found by multiplying 180 times the number of sides the polygon has minus 2. So this n refers to the number of sides a polygon has. So to use it to solve this problem, we just have to figure out how many sides there are in an octagon. An octagon has 8 sides. So we know n in this case is going to be 8, so this becomes 8 minus 2. Let's keep working it out. This is 180. 8 minus 2 is 6. 180 times 6 I can't do in my head, so I'll work it off to the side here. 0 times 6 is 0. 8 times 6 is 48, so we're going to drop down to 8 and carry a 4. 1 times 6 is 6, plus 4 is 10. So the sum of the interior angles of an octagon is 1080, which we can see is B in this case. All right, so that's that one. All right, so 14 says if 4 factorial is the same as 4 times 3 times 2 times 1, simplify the following expression. We have 10 factorial over 2 factorial times 8 factorial. Not surprisingly, I'm going to start by copying this expression down. We have 10 factorial over 2 factorial times 8 factorial. You may have caught on that in math, exclamation point means factorial. And what it says is take the number that's given and multiply it by everything until you get to 1. So 5 factorial is the same as 5 times 4 times 3 times 2 times 1. All right, so let's apply that to 10 factorial. 10 factorial is the same as 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's all over 2 factorial, and I'm going to put these in parentheses so it's easier to see. 2 factorial is the same as 2 times 1, and 8 factorial is the same as 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. In case you're wondering, you do not have to work all this out. If you did, the test would be over before you finish doing that. But that said, you should see that we have some corresponding numbers in the numerator and denominator. And in light of that, we can cross them out. Again, this 8 goes with this 8, so we'll cross it out. 7, 7, 6, 6, 5, 5, 4, 4, 3, 3, 2, 2, and 1, 1. So this becomes 10 times 9 over 2 times 1. Well, what is 10 times 9? That's 90. What's 2 times 1? That's just 2. 90 divided by 2 is 45. So the answer to this one is D, 45. If you couldn't work out 90 divided by 2 in your head, you could always do long division by reading this as 90 divided by 2. And you start by asking yourself, how many times does 2 go into 9 without going over? Well, 2 times 4 is 8, whereas 2 times 5 is 10. So this is 4. Again, 2 times 4 is 8. 9 minus 8 is 1, and we drop down that 0 there. 2 goes into 10 5 times. 2 times 5 is 10, so there's no remainder. All right, so that's that one. I know for a fact that factorials do show up on the ASVAB, so make sure you can work with them. They're not too difficult. All right, so 15 says, find the distance between the points -2, -3, and 4, 5. So I'm going to copy those points down again. We know we're working with 1 point, -2, -3, and another point, 4, 5. All right, so there are two distance formulas. One's distance equals rate times time, and clearly we're not going to be using that formula in this case. And the other distance formula is for finding the distance between 2 points on a line. And that's given by this formula. That distance, d, is given by the square root of x2 minus x1 squared plus y2 minus y1 squared. And again, we can find x1, x2, y1, y2 very quickly. Again, this is x1, y1, x2, y2. So all we do is have to plug things in and simplify accordingly. This becomes d equals, and let's go ahead and do that right now. What is x2? x2 is right here. It's 4 minus, what is x1? It's -2, so this is minus -2 squared plus, what is y2? It's right here. It's 5 minus, what's y1? It's right there. It's -3 squared. All right. So let's keep working this out. We have d equals, let me scroll down a little bit here, the square root of, well, what is 4 minus -2? That's the same thing as 4 plus 2. So that's going to be 6 squared plus, what is 5 minus -3? That's the same as 5 plus 3, which is 8 squared. All right, so let's keep working this out. What is 6 squared? That's 36. What is 8 squared? That's 64. All right, and from experience, I know 36 plus 64 is 100. That said, you may have had to work that off to the side, which is fine. Let's go ahead and do that now. 64 plus 36. 4 plus 6 is 10, so we bring down a 0 and carry a 1. 6 plus 3 is 9 plus 1 is 10. And what is the square root of 100? That's going to be 10. All right, so the distance between the points -2, -3, and 4, 5 is 10. And we use the distance formula to figure that out. This formula is on my reference sheet, so it's one I strongly encourage you to memorize. So make sure you know that one. All right, so 16 says solve the equation for D. We're given the equation A equals A plus B plus C plus D over 4. In case you're wondering, this formula right here is how you would find the average of 4 different data points. So this is the average formula. And I'm going to start by copying this one down. We have A equals A plus B plus C plus D over 4. And we want to solve for D. In other words, we want to get D equal to something by itself. In this case, we have big A equal to something. So we're going to have to rearrange this literal equation to do that. And the first thing I'm going to do is get rid of this 4 from the denominator. I'm going to multiply both sides by 4 to do that. This crosses out here and here, leaving you with just a plus b plus c plus d over here. And we can see this is 4 times a, which is the same thing as 4a. Now to get just d by itself, we're simply going to take a, b, and c and move them to the other side of the equal sign via subtraction. So we're going to subtract a from this side, b from this side, and c from this side. This crosses out here, here, and here, just leaving you a d on this side. And this becomes 4a minus b minus c. And in math, it's customary to write the variable for which you solved on the left. So this is d equals 4a minus b minus c. All right, and we can see that that is answer choice C in this case. And that is that one. Again, this is an example of solving a literal equation. So if you need more help with this, check out my video on solving literal equations and formulas. I think in that video I work out 10 practice problems, including this one. So it should help you if you need more help with that. All right, so that is it for today's video. As usual, you're more than welcome to leave feedback in the comment section below. And as always, I hope this video was very helpful. Let me stress this again. Many of these questions are very similar to what you should expect to see on the ASVAB and PiCAT. And as I mentioned throughout this video, you do have to commit those formulas on my 13-page reference sheet to memory at some point in order to be successful on those tests. Again, my reference sheet is completely free. You can go to my website, asvabapp.com, and download it whenever you want. Apart from that, I'll say this. If you like the content I'm creating, please consider subscribing to my channel. That always helps me out. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.